Okay, so here we're doing Unit 4, Equations, Lesson 1, Algebra, Equation Solving. Now, equations are mathematical expressions that consist of numbers, variables, and operations, as well as an equal sign. The equal sign means that both sides are balanced. So we're thinking that what you have on one side equals the other elements on the other side. And so if we want to change something on one side of an equation, to keep that balance, we have to do the same thing to the other side of the equation. And so if you multiply one side of the equation by 2, you have to multiply the other side by 2. If you divide one side of the equation by 3, you have to divide the other side by 3. Now, when solving an equation, we are said to be isolating a variable. And we can do this through a variety of techniques. The goal is to solve for an unknown variable, and your final step should look like x is equal to something. And that's what we're finding. We're trying to find that variable. Remember, you always have to maintain the equation. I have a real pet peeve, and it happens with my own kids, that they stop keeping it in the form of an equation. You always have to write left side equals right side. You have to have that equal sign. You can't just do your scratch work on another piece of paper and hope that it works out. Okay? Now, general rule for solving equations. You simplify each side of the equation by removing the brackets and combining any like terms. So you're going to deal with those brackets first, then use addition or subtraction to isolate the variable term on one side of the equation, then use multiplication or division to solve for the variable. We have to remember our order of operations, in that I always think of it like solving the equation is kind of like unwrapping a present. So you have to think about it, what order do you unwrap the present in? You have to take the wrapping paper off before you can open the box. Okay. Now, you can check your answer. It's optional, but if you're not sure, you can check your answer by substituting your answer back into the original equation to verify. If the left side is equivalent to the right side, then that means you found the correct answer. So, let's look at the following. 21x plus 5 minus x equals 5x plus 5 times 12 plus 1. So what we want to do first is we want to simplify each side of the equation. We're going to distribute first on this side. And we're going to simplify by combining like terms on this side. So we have 21x minus x is 20x plus 5. And here by distributing, first actually we're going to simplify in the brackets, which is 13, and then we'll multiply. Sorry, we're not going to distribute first. We're going to actually simplify that bracket first. So before I go any further, I'm going to multiply the 5 times 13, and I get 65. Now what you notice is that we want to, I always think about you want to get all your x's on one side and all your non-x's on the other side. So we're going to subtract 5 from both sides. When I do that, well, 5 subtract 5 equals 0. 65 subtract 5 equals 60. Then I want to move all my x's over, so I'm going to minus 5x from this side and minus 5x from that side. When I do that, I get 15x on this side and just 60 over here. Now, how did I get x equals 4? Well, I divided both sides by 15. Cancels out on that side. 60 divided by 15 equals 4. Okay, now again, you can substitute to check. So if x equals 4, then we go back to the original equation, and anywhere there was an x, we put a 4. So that's what I've done here. And then we evaluate each side. Now, don't be moving things from side to side in the evaluation check. You're basically just saying, does the left side equal the right side? And what we notice is, yes, indeed they do. When you go through all that work, we get 85 equals 85. So therefore, that's what those three little dots mean. It means therefore, x equals 4 is a true solution because our substitution verifies it. Okay? Now, we're going to look at type 1 equations today, and then we're probably going to look at type 2 as well. Type 1, a plus x equals b. So they have a variable that is, so we're starting at a simpler level, that is added or subtracted from a constant. Okay? In these equations, we add the additive inverse of the constant to both sides to isolate the variable. The additive inverse of a number is a number that when added or subtracted yields 0. So it cancels that term out, okay? Remember, opposites add to 0. So for example, 5x minus 5x equals 0x or 0. If the constant is a fraction or a decimal, the same process is done. If necessary, review how to add and subtract fractions. So you have to have common denominators. We did that earlier in this course, right? If that happens. So let's do some examples. Okay. All righty. So here, I want to isolate x. So I've got to think about what is the opposite of minus 3? Well, it's plus 3. So I plus 3 to both sides. So x is equal to 12 plus 3, which is 15. Okay, here I want to get x by itself. So it's x plus 12, so I'm going to minus 12 from both sides. So 40 minus 12 is, I'm so terrible, 28 equals x. Okay, and if you wanted to check, you could go 28 plus 12. Does it equal 40? Yes, it does. Okay, here we have x minus 1.2 equals negative 3.5. So the opposite of 1.2 is plus 1.2. And you'll notice I am doing this to both sides, right? Remember I talked about with an equation, you have to do it to both sides or else it is not equivalent. So remember your integer rules. So we have negative 3.5 plus 1.2, and I get negative 2.3. Okay, alrighty, let's do some more. Here we've got a fraction. So I'm going to subtract 2/3 from both sides. Now that means I have 9 over 10 minus 2/3. I'm going to have to find a common denominator, which is 30. I multiplied 10 by 3 to get 30, so 9 times 3 is 27. And I multiplied 3 by 10 to get 30, so 2 times 10 is 20. So this will equal 27 minus 20 over 30, so 7 over 30. Now, you notice through that whole process, I keep the equation with an equal sign and a left and right side. Okay? Alrighty. Now you can see why we did all that fraction work earlier in the course. So here I'm going to add 2.5 and add 2.5. So it'll be 4 plus 2.5. Now you could find common denominators, but it's simple enough with this one just to add the two whole numbers, the 2 and the 4, and we'll get 6.5. Okay, might have been harder if it was a subtraction, and you might have wanted to convert in that case, but in this case we can do that pretty straightforward. Okay, remember we're always looking at the opposite operation. Okay, opposite of minus 2.5 is plus 2.5. Okay, let's do this one over here. Now, before we go further, let's change this. Minus a negative is plus a positive. Okay, so we actually have x plus 2, so we're going to subtract 2 from both sides. So we'll get x is equal to, well, negative 9 minus 2. which is negative 11. Okay? The positive 2 and negative 2 subtract. So be careful with your integer rules when you're doing that. Okay? Now, these next three you should try on your own. Pause the video, come back, and check if you got them right. Okay, I'm going to assume you're back. So opposite of adding 9 or subtracting 9 is to add 9 to both sides. So x will equal 15 plus 9 because these will cancel out. So x will equal 24. Here, we've got x plus 5, so we're going to subtract 5 from both sides. So we'll get x is equal to negative 1. And don't worry if, like if you see here, I've got minus 1 equals x. This is the same as having x is equal to negative 1. You can switch the sides as long as that equal side stays the same, okay? So don't let that confuse you. I know for some people that can be a confusion. All right, here we have a fraction 1. So we're going to add 3 1/5. So x will equal, that will cancel out. We have negative 2 plus 3 1/5. Again, I can deal with the whole numbers. Negative 2 plus 3, I can take away 2 of those and I'll get 1 1/5. If you wanted to, you could do your fraction work. So I could take negative 2 over 5 is the same as negative 10 over 5 plus, and then change this 15/16 over 5, which would give me 6 over 5, and if I convert back, it's 1 1/5. But with this, you could, as I did initially, I could just deal with the whole numbers, and it would work. Sometimes it doesn't, sometimes it's a little more complicated, okay? Alrighty, now you've got some work to do to practice these, and we'll be back for the second lesson in a moment.